Hello, everybody. Can you guys all hear me? Okay, hold on.
Yeah, we can hear you.
Okay, you guys can hear me, right? Sorry for the delay. I don't know why Zoom acting so weird. So I used to have all three classes, three different meetings saved at my main page, the meetings, Tuesday, Wednesday, and Thursday, and today just gone. I don't know why. It's supposed to be there, all three different meetings, but right now only showing my personal meeting ID. That's so weird. Anybody know what's going on here? Okay. Oh my God. Yeah, it's my first time using Zoom this semester. So if anything happened, I'll definitely try to tell you guys in advance. But something happens right before class start. So like, for example, if you didn't see me till like 6:30 or something, please go check with the Blackboard announcement. I definitely gonna post something right there to explain what's going on. And sheer amount of people. Oh yeah, that's true. Yeah, because a lot of companies are using Zoom, like including mine. I feel like Zoom just booming up this year a lot. Before this year, I feel like everybody barely knows Zoom, right? Everybody using Skype or some other stuff. I am talking. Can you hear anything? Probably check your volume. Yeah, I know. I feel like a lot of people inside of the political world, and they know some inside news, and they bought the remote office software like Zoom, and those stock price went up so much. All right. Anyway, so how many are we? Wait, we only have 18 today? What's going on? We're supposed to have like 34. Is it because I showed up like 2 minutes late and somebody already quit? Wow. Okay. Yeah, that's true. Yeah, normally right in the middle of the semester and people just start enjoying their life. All right, anyway, because before class start, I want to do a vote. So I was trying to create a quiz during the past weekend, but I feel like this course is so practical. I can't think of any quiz question. Like all the questions I think of, if I made them multiple choices, they're gonna look so dumb. So instead of giving you guys, a waste time quiz, do you guys want me to merge the quiz weight percentage into assignments? So let me know in chat if you type yes if you agree with me. So your assignment gonna boost from 20% to 30%, and your quiz will be gone. I want to see how many people saying yes, and if you feel prefer the quiz, just say no. At least let me know, because I want to ask all three classes so I can keep the same pace. Everybody in the same page, right? And yesterday's class, pretty much everybody said yes. I didn't see any single no. And I'm gonna do this today. I'm gonna do this tomorrow. And anybody feel uncomfortable with homework being 30%, just let me know. You can let me know in chat right now or email me separately if you don't want, everybody, the other people seeing your opinion. So I'll say if majority of people saying yes and tomorrow have the same result, I'm just gonna change it and I'm gonna update the resume to be like resume. Oh, sorry, not resume. So stupid. The syllabus to be like syllabus 1.0 or something, and I'll gave an announcement for those people who missed the class saying, okay, the rest of the semester we don't have quiz anymore, and please do your homework because your homework just increased from 20% of your grade into 30%. Is that fair? Sounds fair? Okay, great. All right, if nobody's against it, I think I'll go into today's topic. All right. Okay. Anybody have any question about homework 2 or homework 3? Because I posted homework 3 last week, and last week we didn't have lecture. I posted a video on YouTube about 30 minutes talking about design tables and some other stuff. Have you guys checked out that video on YouTube? Let me know in chat who has at least watched partial or full video of the lecture. Yeah, as long as you clicked it, you open it, let me know in chat. 789, 9 people. Come on, guys, we have 20 here. And it's the beginning of the class. Don't don't just close your Zoom and go play some game. All right. So okay, probably half of the people in the class checked out the video, but anything wrong with it? Any question about it? Because I wasn't here to take the answer. I wasn't here to take any question. So if you have any question, you can ask now. So before we get into today's topic, I would like to resolve any question for last lecture. No? All right. Okay. Here's one more thing. So I probably would be a little bit late in the future lecture. Like I'll say like about 5 minutes late because I got a new job this week, so my commute increased from 20 minutes to 1 hour. So pretty much I get out by 5 and I drive home, and yeah, thank you. And I drive home. So I can't guarantee exactly I can be home right at 6 because the traffic. It's an engineering job for making compressed natural gas in virtual pipeline. So you can see when you see those big trailer, those semi truck have a trailer, and the trailer is full of CNG tanks, about like the most is 51 CNG tanks they put in that trailer, and they transfer all those CNGs from the CNG station to the city where it needs CNG. So you don't have to build individual CNG station at the major city because it has a lot of environmental concern. That kind of station really put out a lot of pollution to water and other stuff. So they kind of need that virtual pipeline to transport CNG. That happens mostly between Chicago and New York City. So that's my new job about to design those virtual pipelines. So anyway, so if I'm a little bit late to join this room, please wait for me. So for example, if you wait till 6:30 and I'm still not showing up, most likely there's something serious happened to me. I hope that won't happen. So I'll say most likely I'll be late for 5 or 10 minutes. I apologize at advance. So please be lenient on me. Just allow me to be late for 5 or 10 minutes. But I'll definitely try to be on time at 6 to see you guys right here. Okay. So no question from last week. No question for homework 2 or homework 3. Then yeah, exactly. Because it's kind of scary because I drive 57 the 5 because my workplace is in Irvine and I live pretty close to Kapali. So use 57 and 5, and it's so crazy. I see car crashes every single day on 5 or 57. I used to take 60 because I used to work in Whittier. My commute time used to be around 20 to 25 minutes. And 60 doesn't have that much car crashes, but 5 and 57 every single day, there's a 2 or 3 car crash together. Yeah, 5. That's kind of crazy. So I don't know. Yeah, I hope I'll be fine. And I'll definitely try to be here on time. Okay, so what are we gonna? Okay, yeah, Blackboard. Here, no, here, Blackboard, CPP. Wait, no, the other one. All right, so I posted something under course document last week. I don't know if you guys checked it out or not, called GD&T symbol chart. So it's geometric, dimensional, and tolerance symbol chart. So this is a symbol chart that includes pretty much, I'll say, every GD&T symbol, which you're gonna use on your first project. Remember, I posed the project requirements and I discussed with you guys last week. Sorry, 2 weeks ago. And the project requirements require you use at least 2 customized datums and at least 4 different types of GD&T symbols. So here you're looking at the GD&T symbols that you're going to use on your first project. You're going to pick at least 4 different ones and use them in the proper place. So let's go over this chart. Some of you guys might read it, some of you guys might not. So let's go over it. The first one is called straightness. The symbol is just a line. Sorry. Okay. So straightness gonna show as a line. So you see right here, this box with the leader, this is your GD&T symbol and your tolerance value. So a straightness for 4,000ths of an inch, that pretty much means this edge, you can see this is a cylindrical subject. I'll say that, kind of like a pillar. So this edge gonna have a straightness of 4,000ths of within 4,000ths of inch. Well, this is kind of weird to explain, but because I never see straightness on any application. So let's just read it together. So datum used, no, because you don't see any datum attached after this value. And the funk gauge used, yes, if M is stated. So what's M? M right here is maximum material condition. That condition where a feature of size contains the maximum amount of material with stated limits of size. Example, minimum hole size and the maximum shaft size. Yep. So if this one is stated as necessary for design, then is yes. And tolerance zone type, AHJ. Where is AHJ? Okay, A right here. All right, parallel lines. Yeah, definitely. Straightness dealing with line, right? And H, parallel planes. And plane can have a straightness as well because when you it's a 2D plane, when you look at the sideways, it's gonna like a line. And the AH and J. And J, last one, cylinder zone. That kind of confusing. All right, for cylinder zone, I don't know. Maybe it's just talking about the center axis, like the center line of the cylinder, or is talking about there's a little bore? I don't know. It's kind of weird because straightness can be covered by a lot of different features. Like, for example, if you have total runout or total indicated runout, and the straightness can definitely covered by this feature. So that's why I never see straightness in any industrial application. Normally, if you have like a cylindrical subject like this, and if it has a bore or something to correlate with, or another bigger round of cylinder, so such as this one, you use total indicated runout, so you make sure that two edges of the outside surface of the cylinder, they're perfectly straight. Yeah, because it's not straight, the total indicated runout would it will fail the total indicated runout inspection at QC. So I would say this one probably won't be the straightness probably won't be a very good example. But anyway, it's here. It has a purpose to be here, right? And it doesn't even reference to any data. So if it doesn't reference to any data, that means pretty much this is just a reference by itself. You know what I'm talking about? Like referencing a datum, kind of like a dimension. Dimension is referencing one edge to another edge. So pretty much dimension has two references, and then there's a dimension. If the kind of like a line, you must have two dots, and connecting two dots, therefore you have a line. But this one doesn't even reference anything. So I'll say if you want to use it, do some research to see what kind of application you use this. But most likely this is really, really weak, I'll say. And flatness, no reference datum, but however, this one's kind of critical. I've seen this one a lot. So pretty much if you design for example, you design a table and your table is going to, or a bench, the bench is gonna take some load or some mechanism gonna placed on the top of the surface, your flatness would be very important. Because without the flatness, the stuff you put on there can be imbalanced or rattling. Like those kind of stuff can damage your entire system, especially for natural frequency purposes. So flatness and this value, 4,000ths of an inch, is actually the industrial standard. So pretty much, if you work something with electrical motor and your motor gonna be sitting on a top of plate or top of adapter or just anything, the top surface of the plate or adapter must have a flatness as 4,000ths of an inch or even smaller than 4,000ths of an inch. I have seen 2,000ths of an inch, and that's really, really hard to machine and costs a lot. So flatness definitely a pretty strong one, and people talk about it a lot. Circularity and cylindricity, they're very similar. And also total indicated runout, concentricity, these four, I'll say, they come from the same family. They're siblings. So circularity, you can see this one has diameter of a half of an inch and plus minus 5 thou, and the circularity have a 4,000ths tolerance. So that means two concentric circles cannot be more than 4,000ths of an inch apart. So very straightforward. When doing two concentric circles, you want them as much concentric as they can, right? Because it's off. If it's off, one circle is off place, you'll be in very big trouble. And cylindricity, pretty much same thing. I believe it just one is talking about two circles, and this one is talking about two cylinders. So very similar. Any question about these top four? Let's go section by section. I want to go over one section, and if you have a question, let's talk about it more. And if you don't have question, let's move into the next section. Nothing? You guys still there?
Yep, still here.
All right. Parallelism of circularity. Yeah, circularity just we creating two circles as concentric, and you want that to, like, what is purpose to what?
It means
What do you mean?
perpendicular.
I don't get the perpendicular one. It just gives you an arrow, like which one is perpendicular to which one, like on the perpendicularity one.
Can you rephrase your question?
Like it just
So pretty much
so
you just want two circles as concentric as much concentric as they can.
no, I'm talking about the
Because you know, machinists
perpendicularity one.
when machining like the cylindrical stuff, they hold on one second. Let me bring up SolidWorks so I can do a quick part for you. Oh, that's fine. Why it's so slow? All right, you have a block. For example, you want to mill two circles or two counterbores. For example, two counterbores, and that's your first circle. And let's make a counterbore. Okay, so you have like a counterbore right here, and let's do another circle. And you want them to be concentric, right? Okay, so pretty much you have a bore and a counterbore. So these two circles are concentric, right? And how can you make sure these two circles are as concentric as you're asked? Pretty much you can't, because machinist, you said, okay, machine these two circles origin at the same point. Machinists can understand it, but the machine doesn't, right? The operation, when you guys get into the manufacturing lab, when you start using lathe, or this is going to be created by milling, the milling machine, they can't identify the origin of the circle. And that's why you need to tell them how much tolerance you're going to take. That means tolerance means kind of the risk, how much tolerable you are okay with your part. You want this to be perfect concentric? No way. Unless you're paying like a lot of money for some high precision company that using like the leading edge tool to create it, maybe there's a possibility, but most likely it's not going to happen. So that's why you're going to set a tolerance saying, okay, these two circles, if they're not concentric, but the distance of the two origins are less than 4 thousandths of an inch, that would be acceptable. So the machinist will say, okay, that's doable because my tool is not that precise, but 4 thousandths of an inch should be enough. You know what I'm saying?
Yeah, I get
So
it.
that's when you use circularity. Yeah, same with cylindricity. I believe this is just like a bushing. So two cylinders, right? One cylinder is when making this bushing, and another cylinder is a hollow cylindrical shape within your bore. So pretty much instead of two circles, they want okay. So circularity only controls this circle highlighted and this circle. and cylindricity controlling this surface and this surface. All right. So pretty much, if you use circularity, they're just gonna measure this circle and where's the origin and compare with this circle's origin. And when you use cylindricity, they're gonna measure all the way through the surfaces, any spot on the surfaces, and compare with any spot on this surfaces. So pretty much is the difference is like point to point versus surface to surface, something like that. So kind of like, 1D versus 2D, that kind of stuff. All right, I'll move on. Parallelism. Oh, no problem. Anytime, man. You just need to ask. Parallelism is, okay, right now the datum start kicking in. So you can see it has a little box right next to the value. This is datum A, and you can see the datum A, it shows on this diagram. And datum A has a little leader and to this edge. That means the datum A is this edge. So, okay, before we get in the datum, let me show you the definition of datum. I really can't remember the textbook definition. All right. So datum is a plane, is a straight line or a point that used as reference when processing a material or measuring the dimension of a target. Okay, so remember this definition or remember in your own language, like what I did. So the datum in this case can be an edge, right? So for example, this block, the datum is the bottom edge, and you want your top edge to be parallel with the bottom edge, and the difference of amount of magnitude for two parallel lines cannot be more than 4 thousandths of an inch. I hope that explains. So it kind of like, it can be, well, okay, here it says better. So two parallel planes, 4 thousandths of an inch apart. So your line cannot be going over that plane. Okay. You see this pretty very often, same as the circularity and flatness. Yes, yes. So I will show you later. Well, no, it won't automatically show up. You will need to manually input the symbol type and the tolerance value for your dimension. And perpendicular, well, whatever, perpendicular. Perpendicular, same thing as parallelism, just this one is 90 degrees apart. So these two very similar, but does different job. Angularity, I never used it. I never see anybody use it. Anybody who still recall what we done 2 weeks ago, making the weird pyramid and a lot of angles within that model, right? Kind of like a little pyramid, that's kind of stuff, weird shape. But we never even define any angle, right? Why? Because the model is fully defined by all the distance from this edge to that edge, from this point to that point, stuff like that. We don't need to define any angle. And if you forgot, just go back to YouTube to watch the lecture video again. So normally we don't define angles in drawing. When we do, we normally don't do angularity because this one is really it's correlated with too much factors. So I'll say try to avoid it, but maybe you're in a very special industry that uses a lot. It just, I don't know. I never seen anybody use this. So I guess, so this one is just talking about this angle, and they don't want use the default tolerance of this angle. That's why they have this angle reference to this datum A and gave us a tolerance. And you can see this angle has a box on it. What does this mean? That means this dimension is a basic dimension. Basic dimension means this is theoretical value, which will never be achieved. That's why I call it theoretical value. That's why I call it basic dimension. And basic dimension always have a GD&T reference or GD&T symbol attached to it. So I really don't know the purpose of existence of this angularity, because your angle can always be regulated by the default tolerance, right? Or you can just right here saying plus minus half degree or something like that. I don't know why they use angularity, but anyway, if you read into it, Google it, and maybe you can let me know. So profile of a line and profile of the surface. I normally don't see this, but let's read it. Two lines, this amount apart, along true profile. So kind of like just a curvy straightness, or is it like a curvy parallelism, right? So the profile is regulated pretty much by two boundaries. The first boundary and second boundary, which are dashed line right here, and they cannot be more than 4 thousandths apart. And this one for the surface, pretty much just profile of a line versus profile of a surface is very similar to circularity versus cylindricity. One is talking about a line, one is talking about the entire surface. And its own characteristic is very similar to parallelism. Okay, circular runout and total runout. So total runout and pretty much covers circular runout. So this is kind of like parent and child. So if your company don't want to do the entire tracking band or something, want to reduce the cost for manufacturing and QC, they probably do circular runout. But this one only regulates, I believe, one side, right? Concentric circle, this apart, and this one is two concentric circle, and these apart. Yep, so this is going to control one side, and this control both sides. And total runout, very powerful and very expensive. This is very strictly used in any rotating components. So anything that's going to rotate definitely will have a total indicated runout inside of its bore or outside its shaft or on both. So if you're making your project a rotating component, such like a gear train or something, anything rotates, this one you can't miss it. Any questions about like the second part before we move to the final part? No? Okay. Okay. So next one, position. Position, very, very common. Probably the most common one you're gonna see, because if there's a hole for fasteners, for bolting or fasteners, the position gonna show up for all the application, unless you make the hole big enough that you don't even worry about that the two holes that you're gonna fasten with are gonna be off place. So let's bring up the example right here. If you want to connect two plates together, you're gonna make two holes, one hole on the left plate, one hole on the right plate, and then you're gonna put bolting through both and then fasten them together, right? If you guys can imagine or brainstorm. So these two holes cannot be at the exactly same location. Like I mentioned before, the machine cannot do the same thing. unless you machine the two plates at the same time at the same spot. Pretty much, just sandwich the two plate and then just drill one hole like that. But that's not gonna happen in the real world. They're gonna machine part by part. So that position of the hole will be different, even though your drawing will be this, even though it come from one drawing, right? But how much off is controlled by this tolerance. So you can see the reference has A, B, and C, all three right here. This is a lot. So A pretty much is the direction that going to page. That's why it's not attaching to anything. And B gonna be the vertical edge. So think about y-axis. And C gonna be the horizontal edge. That's your x-axis. So pretty much this hole is regulated by 3D, X, Y, and Z. And all three location or all three dimensions cannot be off more than 14 thousandths of an inch. So this is pretty much it's talking about. So you can see that from here. So 22 thousandths of an inch zone LMC. What is LMC? Okay, limit of size rule, one only a size dimension, beyond the envelope between. So MMC is minimum, right? Minimum material condition. Okay, least material condition. Okay, so one is maximum, one is least. So one is minimum. All right, where are we? Okay, right here. So this one is this big at the least material condition, and 14th of an inch zone at maximum material condition, and true center. Wow, this one pretty much explains nothing. Okay, 4 thousandths of 8 thousandths. Okay, I get it. So when 14 thousandths of an inch, right? And this hole is a quarter hole that have a plus minus 4 thou. So the maximum, the hole, like the hole's location can be off by 14,000 plus 4,000 plus 4,000. So that's 22 thousandths for the least material condition. How to say that? So is this much off? Anyway, so pretty much this 0.62 from datum C can go above this much or less than this much. Let's get a notepad. Yeah. So this 0.620 dimension, you can see from the center of the hole to the reference C can go plus or minus this much. And that's your least material condition. Okay. And your max material condition is pretty much same dimension and plus or minus this one, because you can't go smaller than this. This is making sense? And the same rule applies to this 0.38. Any question? Well, if no, just move on to concentricity, because this one's just a very common one, and for every hole, threaded hole or non-threaded hole, as long as there's a bolt goes in, you need to have this tolerance stated to secure the hole location. Okay, so we okay, so this number is added up by your tolerance value and plus the hole's tolerance twice, because your hole has a tolerance and this dimension also has a tolerance. This is sort of making sense. Yeah, it's kind of a weird way to express it. Yeah, just after you get your manufacturing lab, when you start milling holes or start tapping holes, you understand that really easy, because the machine is sitting right there, and how do you adjust the machine, and how much what kind of math you're going to do, and input the value to locate the die. Yeah, they call milling the die, right, or something like that, or the tap, and then you'll fully understand it. Yeah, but for now, just know this one is really necessary for fastener hole stuff. Concentricity. This one is very similar to Renault, but is less strict, because this one is just talking about the datum axis and the outside outer surface, OD. Yeah, talking about the OD and the center datum. So you see, this one has a very similar diagram as the parallelism. Unlike this one is really strict by its outside surfaces. See? So I'll say concentricity pretty much has the same power with the cylindricity, but deals with one data. This one doesn't have datum, right? Yeah, this one doesn't have datum. This one's controlling all the outside, like two surfaces, but this one is controlling one surface with the datum. And the datum you can set as the center axis, or you can set something else. And symmetry, never seen it. I don't even know why it exists. Maybe some industry uses this a lot. I don't know. Because normally it's just easier to identify all parts, even though it's perfectly symmetric. Like your part is perfectly symmetric, but it's still, it's just easier to define the whole thing. And you put symmetry right here, might confuse somebody. So I'll say this one, similar to straightness. You want to use it, you got to do some research. But like for all kinds of drawing that I have seen, never seen this. Okay. Any questions? No, nothing? Okay. Let's talk about you guys care the most, this project, right? All right, here we go. All right. All right, everyone can see this one okay?
Yes.
Hello?
Can you?
Yeah,
Can you
we
not?
can see it.
Can you not hear us?
Thank you. Just Jacob alone. This is about your first project, guys. Yeah, I can't hear you. What's going on? Is it I mute something? Yeah, I can't hear you guys. What?
Can you hear me?
So weird. Ah. Can you try to speak something again?
Hello, testing.
Yes.
Can you hear me?
Hello.
Can you hear me?
Yeah, I can hear you guys.
Okay.
Okay,
so
okay,
so
okay.
sorry, so dumb. Like my headphone has a controller by itself, and it has so many different modes. And I turned off one of the mode, and it just become entirely muted. Okay, I feel much better now. Yeah, so look at this drawing. This is my expectation for project 1. You don't have to make as complicated as this one, but the way it dimensions and the dimension you use and the datum it labeled and the GD&T symbol are, my is my expectation. Don't worry about the welding. This is the welding symbol. It just being there because I have to take the entire shot, and ignore this.
For the A, B, and C, does it matter which datum you choose as A, B, or C, or you can just do whatever? Which ones?
You can do whatever, but
Okay,
you have
okay.
to make it correct. So, okay, you choose A, B, and C. For example, let's go over this. For this hole, the position referenced all A, B, and C, right? And we don't see datum A right here. It's probably in another view, but anyway, just let's assume something to be datum A that can be used. So what can be a valid datum B? Look at datum B. The B is referring to this edge right here. And maybe you guys cannot see what kind of shape of these this bracket, because I only took one view, right? It's proprietary to my company. I can't take the whole thing. I don't want getting trouble. Anyway, so this is a bracket. So look like a bridge. So if you look at this way, and the holes, all 8 holes, gonna be poked through here, and this side, like the bottom side, right here, gonna be my risk right here, and these two support. This one and this one, you can see 2 very skinny support because this is the bottom view. This one is bottom view. The 2 support gonna be like ribs right here. So one is right here, one is right here. And the thickness of 9.52 right here is actually the thickness right here. So 2 ribs has thickness of 9.52. I hope you guys can visualize it. But anyway, B is on this leader line, right? This leader line shares one dimension 87, another dimension 18.5, and third dimension 9.52, right? So when is referencing datum B for 1 millimeter, this is in metric, it's 9 inch. For 1 millimeter, that means this hole's position referenced this side of the wall of the rib, can be no more than 1 millimeter. And this tolerance goes into dimension 18.5. Why is that? Because 18.5 is a basic dimension. It's a theoretical dimension, has no tolerance to control it. It's not going to the 87 because 87 already has its own tolerance. It cannot go 9.52 because 9.52 already has its own tolerance. So we don't want it to stacking up tolerances, just like the math I did prior to this picture. Okay. And datum C is this edge. This edge shares this 42 and 285, just 2 dimensions, right? So the datum C for this value does apply to the 42. So is it understandable?
Yes.
Okay, good. So that's how you set your datum, because you gotta set your datum first and then do your GD&T. But by the time you're setting up your datum, you already know how you're gonna set up your GD&T. That's why, you know, if you set the wrong datum and when you're doing GD&T, you say, oh, it can be referenced. For example, if I move this C to bottom, like this edge right here, it can't be referenced on this 42 anymore because this C is not on, like this 42 is not controlling this edge. So you get, do you guys sort of understand this? Sorry, I should find a better way to make this easier, but just hard to express what I thought in my mind right now. So pretty much your datum and the dimension who control the datum and control your subject must be correlated, must be sharing some same reference. Okay, anyway, let's look at this, the parallelism. So the parallelism is staying under this 87. It's because this GD&T is specifically controlling this dimension. So unlike the positioning, this one only controls this dimension. And also this dimension is referencing B because just accidentally B is one of the side of the dimension that it's trying to control. So if this B doesn't exist here, it can still use the parallelism. Is it clear? I hope you guys all understand it. And since we don't know where the datum A is, I probably just not going to talk about
I get it.
Okay. So it seems like the datum A is going to be one of the horizontal edge because this is perpendicular and 9.52 is controlling the vertical, like this vertical edge, right? Pretty much 9.52 is the thickness of the rib. And the leader line is controlling this vertical edge, and we want this vertical edge to be perpendicular with something, so it must be a horizontal line, but just datum A is not shown right here. I'm not sure where the datum A, I was not very familiar with this product, but I still want to show you guys because this is a very good example for your project 1.
Are the datum like set in place, like, and then everything else is positioned off them?
Yes.
Okay.
Yeah, it must be. So pretty much your datum should be one of your leader line, if that makes sense.
What do you mean leader line?
Leader line is this. This line is leader line. This line is a leader line, and this arrow is a leader line, but arrow type.
Okay.
So your leader line is leading a dimension to your reference. That's called a leader line.
Okay.
Yeah, because this is a whole, and right here just its own definition. That's why this leader line doesn't count because it's really just pointing something, is not referencing anything. But look at these dimensions. That 2 leader lines are the critical reference, right? If you reference something wrong, your leader line should not be in this place. Yep. exactly like a reference point, but you can't call it point. You should call it reference datum, because datum covers point, axis, plane, surfaces, stuff like that, everything. Yeah, point is, the word point is too narrow. All right. So for next week's lecture, I'm gonna do a drawing from scratch to show you guys how to make this happen, how to make the GD&T, how to define datums, and how to make basic dimension, and when to make basic dimension, stuff like that. And I want to show you guys a very brief example on SolidWorks. Okay, so probably a lot of you guys gonna have a question: what kind of part I should create it to include 4 different GD&T symbols, right? Because all 4 GD&T symbols seems to have so many different jobs, right? How can you link, for example, circularity with position, or concentricity with flatness, something like that? I just want to show you guys a very brief example, and don't use this for your first project because it's not good. It's too easy. So let's make 1 concentric circle, 2 concentric circles. And let's make another little hole, just wherever. All right, so this one look like a sleeve, and this little hole I just made can be a set screw hole. You need to have a set screw to secure the sleeve, and this sleeve is going to be on a rotating shaft. So for a simple part like this, how many different GD&Ts we can use if we really want to make this part perfect? So for example, this cross section, pretty much the top part of the sleeve, we can use flatness, even though we don't have to, and nobody in industry really care about this surface. Pretty much it's because no radial load gonna be taken, well, not radial load, not like no normal load gonna be exerting on the surface. So pretty much nobody gonna care about the flatness, but we can if we really want to, because we're just doing projects, right? So flatness can be on the surface, that's 1. And here we have a bore that's going to connect with the shaft. Even though this one is not gonna rotate, but your shaft will definitely be rotating, right? So you want to put total indicate ran out, which is this one. The total ran out, you can do that, even though it's not necessary, but if you really want to, you can do it. I mean, they won't say, like your engineer won't say, sorry, sir, your design is not feasible. They will just say, oh, you're such an idiot, gonna cost so much on some unnecessary machining. So you can definitely do that. So that's 2, flatness and total ran out. And the third one, what else we can put on here? This is the set screw hole. So it's gonna be threaded, because all set screws pretty much are threaded. So I didn't put the cosmetic thread here, but you should. I showed you guys how to do cosmetic threads 2 weeks ago, and put cosmetic thread here, and you can use positioning. And the positioning is gonna reference with the center axis. And okay, let's view it this way. So the positioning gonna reference the center axis and this side of the edge, and the top tangent, the top edge, which would be like a tangent plane. So that's your A, your B, and your C. Okay, so 3 GD&Ts we have used. So one flatness and total ran out and positioning, and what will be the next one? The next one you can do, I'll say, let's check. Circularity, right? So you ran out controlling the contact surface with the contact surface of the bore with the shaft, and your circularity going to control the entire outer surface of your sleeve. So you're going to put the circularity respecting this edge and the bottom edge. So one very simple part, and if very necessary, you can put 4 different GD&Ts. Does that make sense?
Yes.
Okay, great. Thank you. Well, don't use this as a first project. This is just a very easy demonstration, and I hope you guys can use your creativity and imagination to make all your GD&Ts feasible and reasonable. So very similar to the drawing I just showed you, this one used 3 different ones, and you know, you can always add a 4th one, like respecting from here to here, put like something, you know.
So 3 is the minimum?
No, 4 is minimum. You
Oh.
need to use at least 4 different ones.
Okay.
Mm-hmm. So next week, I'm gonna show you an example about using 4 different GD&Ts and create a drawing similar like this. And for this week, you guys need to make up your mind on what you're gonna draw. All right. So for many of you, if you don't know what to pick as your project 1, just search machining components on Google. Go to image. Here you go. So many different parts. And pay attention, these are not assemblies, these are parts. And the part is it's more than enough for you to pick to make your project 1 drawing. All right. So for some of you want to be fancy, you can use some parts like this. I don't even know what does it do. And some of you want to be a little bit easier, do like this. You know, this one kind of like the metal plate sitting on top of the stove or something like that. I don't know. But just make your pick this week. So by the time next week when you're watching me doing the drawing, you can start brainstorming how you're gonna make your own drawing. Okay?
Professor, I had a question about that.
Yes?
So say, could we use a part that's going to be involved in our final project for our first project?
Yes, absolutely
For
you can.
example, like me that I'm building the engine, and for my first project, can I build like the piston or the engine chamber?
Yes,
Okay.
you absolutely
Perfect, thank
can. Yes. This idea, just for some of you guys don't even know what you want to do. Because I receive emails like saying, I really don't know what to do on the first project. What kind of suggestion you can give me? I told him to go right here, pick one. Because I can't really say you do this, you do that, and you know, there are so many students out there. So if you understand it and if it makes sense, just say okay in chat. Wow. Nice job, guys. Thank you guys so much. Yeah, it kind of surprised me. Still, half of the class still paying attention. Okay. So, any questions so far? I'm about to end here. And any question about homework, about project, about what I just showed you, ask right now. And if you have no questions, you're free to go. It's due November 1st at the midnight of November 1st.
Is the homework from last week the same for this week, or is there different homework this week?
It's different.
Okay.
I mean, homework 3 apparently is different than homework 2, right?
Yeah. Okay.
Yeah. And I wrote the instructions with homework 3. I believe you can see it from Blackboard, right? Wow, that's kind of weird. The description is not there. I did type a description.
I was really confused on what to do. I just saw a bunch of shapes.
Yeah,
Yeah.
me too. I was like,
I see a grid in shapes.
I'm so sorry, guys. I did add a description to it. I don't know why it doesn't show here. This is so weird. And this one is... Okay, anyway. So for homework 3, you can see those are projections. So pretty much what you did for homework 2 is I give you models, you guys make projections, right? This is reverse. You have projections, you need to make models. So, oh, is that announcement? Okay, thank you so much. I've been so dumb. I forgot what I did. Okay, homework 3, please create 4 model is based on its projection drawings and submit the SolidWorks screenshot of isometric view of each model to Blackboard. So, you know, Windows has built-in snipping tool. Use snipping tool, take screenshot, and save in a Word doc or whatever, and then, you know, submit it into Blackboard.
So is the isometric view like the view where it shows like an angle of like the top, the side, and the front?
So if you can look at my screen, this is the isometric view, and if you
Ah.
click on it, here we go,
Okay.
isometric view.
All right.
Yeah.
Cool. Thanks.
Yeah. So it's one of the default views. Won't no settings involved with it. Alrighty, guys. Is GD a tolerance? What do you mean? GD&T means geometric dimension and tolerance. Like on the drawing. Threads? Threads, no, you don't tolerance threads. You tolerance the whole position. The threads, you use standard threads. You see those SO threads or NC threads, and you just define the size of the hole, and they're gonna automatically produce the threads. Can you rephrase your question, Joseph? I don't get it. What do you mean? Is GD a tolerance like on the drawing? What's GD? Oh, for those of you who don't have any questions, just you're free to go. Enjoy your night. Grab some dinner. The box dimension called basic dimension, that's completely different. That's not a tolerance. That's a basic dimension, and in Wikipedia, you can see here there. Basic dimension is theoretically exact dimension. So just a theoretically is a theoretical value. So it's a type of dimension. It's nothing to do with tolerance. It's not controlled by tolerance though. Any more questions?
Professor,
Yes.
I have a question about the homework, if you don't mind.
Sure. Which one?
So the homework that is due tonight, I've done all the pictures and I was just like checking the solutions with the one that you posted. And I think I'm doing number 5 wrong, not sure. I thought I was doing it right, but then I checked it again and it was like not the same as the solution that you posted.
Mm-hmm.
So I don't know if you have the picture opened right now, but if you look at number 5,
Mm-hmm.
it has like a stair kind of shape at the left side.
Yes.
And on the solution, it's more like, I don't know how to explain, but it's like a square. It's not a straight line, you know?
Yeah, pretty much it has a hidden part that you can see and you have to make assumptions and right.
No, yeah, I understand that part. It's only that, you know, like when you count the squares, like the first square, the second square, right?
Mm-hmm. Mm-hmm.
And then on the second square, on the second row as well, on the second column, second row, shouldn't it be a straight line on the left side?
Oh, okay. Wow.
You know what I mean?
It's very specific. I have to open up.
Oh, sorry. Okay.
No problem. Yeah. So what about the second square?
So if you look at the solution, like looking from the top view, right?
Mm-hmm.
I assumed it should be like a stairway kind of shape from the left to the right on the second row, second column to the first row, second column. You know what I mean? Because when you
Yes.
look at the picture, and it's like a straight line instead on the solution. So I was not sure.
The
if
top
this-
view, I think. Right? You mean? That's what you mean? Yeah.
Yeah.
Oh, it does. I see. Yep. So the solution is wrong.
Oh, okay.
I'm sorry about that. Yeah,
No,
it's supposed to
good.
be.
I was just afraid to submit it because I was like, oh, I did something wrong then, but okay.
Didn't I also email you about that too?
Yes, you have.
Okay. Yeah.
Mm-hmm. Yeah, but I wasn't looking too that deep because I was at work. So
No, it's very confusing.
Yeah, no problem, no problem. Actually, yeah, this one is super wrong. It has to have the saw teeth shape right here. But, this one doesn't have. So apparently, whoever made this solution is very incompetent. All right. Yeah, I really appreciate your pointing out, and definitely, actually, the way I grade the homework is very lenient. So as long as you didn't draw some Mickey Mouse, I'm gonna give you full credit. So pretty much the homework just help you practice with solid work. Yeah, if you be very offended, I mean, you know what I'm talking about, right? Yeah. I'm not that old, so I'm kind of easy to be offended. Just kidding. Just kidding. All right.
Thank you.
Yeah. So definitely, good catch. Alrighty. Anybody else? Supposed to do that on paper. Yeah, so you have two options. One is hand draw on paper, and another one is do by SolidWorks and the harder way. So up to you. Hand draw on paper, I'm pretty good with hand draw on paper, But if you really want to, you know, spend time with SolidWorks and practice yourself and that kind of stuff, do it by SolidWorks. I encourage you to do that as well. Man, you better start doing it. It's due tonight, right? I forgot what due day is, but homework now is 30%. If you allow me to remind you. And I would say homework is really like free 30%. As long as you do it, I see you try it, I'll give you full credit. Okay, so this week, you need to start selecting the component that you're gonna draw. All right, so before you came to class next week, you supposed to have a very explicit idea about what you're gonna make, make the drawing with, make the drawing off. So you can start the project after next lecture, because next lecture I'm gonna show you guys how to make the drawing like what I showed you in a picture. So pretty much it's like do an example for you. Yeah, I think so. As long as you can design the gear that fit with 4 different GD&Ts, because like the gear has so many different configurations, you know, and you can definitely take a look into it. If it's just a plain gear, I don't think it can fit all 4 GD&Ts. But if you do like a screw gear or worm gear, something even some gear even take, you know, axial loads or something like that, you know, definitely can work. Yeah, spend some time, man. Anything else? All right, if there's nothing else, I'm gonna leave the meeting, and anything go across your mind, just if you're not sure, just ask me through email. All right, guys, have a good evening then.
Thanks, Professor.
Thank you
too.
very
Thank you.
much.
You too.
You too. Have a good night. Bye-bye.
Bye.